So here we are again at the Renaissance in Long Beach, California, and we are continuing with our Amz5x12M matrix application. And we have taken a 5x12 from a real life situation, and we have actually borrowed our sample this morning. Yeah, we borrowed our samples. That's the amount of faith we have, so it could produce these things. And we have left this over to the authority, to the Federal Reserve and to the Treasury to do the rest for us. So these were actual samples, and we could take in the samples from the variety of monetary bills, but we chose the big bills this morning as we have a big problem at large. And so moving away from the economic application, let us try to set up our board here. Let's put like a weight on this side here. Sorry for the interruption. Let's try to put a weight, like a seesaw weight here to balance it. Let's see. Can't put too much there. All right. And so we continue with our engineering analysis, and notice we have left out a lot of steps this morning. And from the component matrices, we have a 2x2 sample here with a 2x2 circuitry, and we have just randomly used some of the, like this will be 4 ohm, how we're operating in pairs now. 0.40 ohms, 0.72 ohms, 0.98, all these numbers are taken from the arrangement of the 5x12 sample. And we have 2 volts and 5 volts. So this would be like a relatively small signal analysis with these 0.72 ohms and so. And so for this one we have a 3x3 sample, and likewise we have taken these numbers from 626548 randomly from the 5x12 matrix after it is broken down into its components via the PDM processing. And this is a 4x4, and notice in the real thing we have these by inspection, by taking these are like the elements, the paired elements, the 4-0, the 9-1. Let us find a 9-1 here. 9-1 here would be like this. Let us find a 4-0. A 4-0 would be like that. Let us find a 12. A 12 would be right here, paired. 4-3. A 4-3 would be right here, and so on. And so we have also did a 5x5 thing, and we have a 0.13, a 0.12, which are elements of the matrices. And notice we have also some inductance, which would be in henries, and some capacitance. And this would give a complex analysis, signal analysis, with some J's and some I's, whichever one you choose to use in the solution. But all this we have done, and I've made in lectures of this so far, so you could research the lectures given on these circuit analysis, and that you will find that all these are already done. So this morning we are just giving some samples of it here at the Renaissance in Long Beach, California. So we have a 2x2, a 3x3, 4x4, and some 5x5 matrix here. And these are like one of the components which give you the 3x3. This one gives you the 2x2, and this one gives you the 4x4 paired, and this one is like a 5x4. So there we have a short version of some engineering circuit analysis, which is done by using the components now of the 5x12 matrix after it has been broken down via the PDM processing. And so this 5x12 matrix really have a lot of applications, and uses. So engineering students can go about and do the calculation of these via the parameters, which are the elements of the 5x12, 4x4, 3x3, and the 2x2 matrices. So you could go ahead and do the down method of analysis, which we have done in certain sampled presentation, and it could also use a matrix program to do some of these larger ones, which would prove a bit more difficult, nevertheless challenging, and it's an exercise for the engineering student to do. So all right, we're going to conclude this section of the amazing 5x12 matrix and PDM processing at the Renaissance Hotel in Long Beach.